Actually, it was better over there. Whee. Oh yeah, that's good. Yeah, Jeff.
I'm gonna tape you guys.
Tape your reaction. It could be like a reaction vid, like audience watching Paranormal Activity or something. All right. So there could be a problem like, and really, to be honest, the problem where there's a person standing here and they looked up to the top of the building and they saw this antenna and the angle of elevation to the bottom and the angle of elevation to the top. Right? That was one problem. It's really the same as somebody sitting up on top of the parapet in the castle, and there's people coming at them, and the distance between them, the angle of... It's exactly the same problem, just turned around. Right? You guys remember that problem? And the problem with the hobbits who were walking to Mount Doom, right? Because the eagles, for some reason, can only come in at certain times. So... it doesn't really matter which one to pick. I've already drawn this picture. So if I say the angle of elevation to the bottom, is, let's see what makes sense here. Let's make it 41 degrees. And to the top is, what you got, Jeff? 46 degrees. And let's say the building is, let's say 1,400 feet. I don't know how tall is the antenna. I don't know what I told you about the test. So what can I do?
Take a tangent from like the bottom and the side.
So what I would do is, if I were you, for example, if any of you have to take any physics, anybody have to take any physics in their future? When you get there, you're going to be representing cars as points. You're going to redraw the picture. You're not going to draw the car. You're going to draw a point, and that's going to be the mass of the car is all centered at its center of mass. It makes the drawing a lot simpler. So this is this is a fantastic, beautiful drawing. The dude, Da Vinci, did it himself. Okay. But now you want to come over here and just make triangles. I mean, here's one triangle. What could I put where? Where would this go? So that's this triangle here. So what's this here?
1,400.
1,400. What angle goes here? 41 degrees. Cool. And then I got this triangle, a little bit bigger. What angle goes here? 46 degrees. And how tall is this?
1,400.
I'm going to call it Y. Why would I call it Y? Just because in the Y direction. Alright, these are independent of the way I've drawn it. Alright, cool.
The last angle. Doesn't matter what the last angle is.
The last angle? It might, if you want to get it. Yeah, you could get it if you wanted to. If you wanted to use a law of cosines or sines, what would two things you'd have to get. One thing is relatively simple. Can anybody tell me what triangle would you want to use the law of sines or law of cosines on? No, I wouldn't have to use the laws of anything on those two because those are straight up right triangles.
The
little wedge dude here, right? And the only kind of advantage is it's directly related to what you want. It's directly related to y, right? How are we doing? That is another way to do this. Not the way we're doing it right now. Another way is to do that. Can you tell me what this is?
5.
5. Yeah. 5 degrees. And then what would I need to continue. What could I do between, there's a ratio there, right? I would have to know a complete other ratio. Is there? So now what you were saying earlier, Joseph, is I know what this angle is.
Yeah. 44.
All right, 44. So I know what this angle is. You guys semi with me? But do you see how you have to do? Maybe it's a little more work to do that because I have to know at least one of these sides, right? You guys understand that? So I could figure out the hypotenuse of either one of those right triangles and put it in there, and then I can make law sines. I can make a complete ratio. That's a whole other way to do the problem if you want to. Or you can do it like that. Either way.
Are we allowed to do that now?
Yeah, totally. Let's see. Let's do it both ways real quick because you know you're probably going to get both kind of problems anyway. So how would I do this problem? So what you need to realize is you can introduce, for both of these triangles, even though I've drawn it horribly, how long is this?
X.
Yeah, it's something. It's x. Cool. Like, do you care about x? No, but they connect the two, don't they? So you could solve one for x and plug it in the other dude, right? Do you guys see what I'm saying? That's your connection between the two. So you can make an equation for this. What equation would you set up for this? Tangent, 41 degrees, become what? Equals 1400 over x. Cool. Here you get tangent of 46 equals y plus 1400 over x. Solve one of them for x, plug it in the other dude, right? Is that cool? So I would kind of work a little bit with both. So this would be x equals 1400 over tangent 41 degrees. Is that cool? And then this one I just do a little bit. I'd say, well, if I solve this for y, it's kind of awesome. So y equals x tangent 46 degrees minus 1400. Is that cool? And now I can just plug that x in. And I'll get what y is. That was relatively simple. The thing you had to realize was you needed one more connection between them to actually set up the system of equations. All right, maybe. The only advantage that doing it this way offers is I don't need that connection. I'm just going to focus on this wedge. But like we said, you got to get one of these two. What's the ratio I can set up for law sines that relates what I want to something? What do I want? I want y. So what's the ratio I can set up? Sine of 5 to y. And now I need sine of 44 to this, for example, right? So I have to get this hypotenuse. Now think about it. How would I get that hypotenuse? What do I know about this guy? Hopefully you guys are with me. You realize that I've got two different methods up here, right? You guys understand that?
To the second plus.
I got one method is this way with the tangents, and then you're basically done here. You just plug that in and plug it in your calculator. You're done. Now I'm looking at a whole different method. Using a little wedge here. It's not a right triangle, so I have to use a law of fill in the blank. Right? So yeah, what would I use to get this?
The sine of 41.
Yeah, sine of 41. 1400 over question mark. Sweet, all right, and then you can get question mark. And once you get question mark, you can put that here. That'll be 44 degrees across from this. Is that cool? You guys semi with me? So you can do it either way. That's why, I don't know if you remember this, but just in case some of you guys got ahead, and some of you guys did, on test 4, I think, whatever it was before we got to law of signs, on that one problem I said you may not use law of signs for law of physics. Because we didn't officially know it. I didn't want you to do that way if you knew it. Alright, let's make sure we get the same answer both ways. Somebody help me out here. What do you get for question mark?
400 over sine 41.
That's okay? Nope, what do you get for? And to be honest, I mean, if you didn't want to round it all, you could plug that whole thing in there.
2,133.
2,000?
134 right there.
34.95?
No, wait.
33. Yeah.
Alright, cool. Alright. You guys with me on that? So that's the hypotenuse of the smaller triangle. That is a side of the wedge at the top, right? So now I can use, I've got this written. Now I can make a complete ratio, sine 44 to 2133.95. So if you do this, what do you get for y? You solve this. I guess you can watch me just trying to do it. Imagine me, I'm trying to do this in my head. Just saying, because you guys are not telling me anything.
2015.
What is it? Do it again?
267.74.
267.74? Alright, it's a big ass antenna.
Yes.
Cool, I like it. 267.74. Sweet. What do we get if we do that way? Is that true? Did you actually do it? I like it. Sophia's just like, you have to, man. I just know. But yeah, you did it. Cool. I like it. So if you took this number, whatever the number is, plug it in there, do this, get the same thing. Of course, you have to get the same thing. So we set both of them up correctly.
The antenna is bigger than the building.
The building's 1,400 feet. The antenna's
Oh, I
260.
thought that was 2,677.
No. That's right. Yeah. No. That would be a true space number. Yeah.
Could we do number 10B on the practice line?
Let's find out. Alright. So I'm actually doing log properties with my 103 students. Of course, we did a little bit more with logs, but this is just a basic log property problem. But right, you're looking at the 2ln, that one. What do I have to do first to be able to apply my properties correctly? Yeah, do it again. Yeah, I gotta get the 2 out of the way. I don't have any properties for twice a log minus another log. I have a property for log of something minus log of something. So I get it's 2 out of the way. Thank God it just goes right up there. And now you rewrite the differences as the difference of 2 logs is the log of the. What do you subtract powers? What do you divide? Right. So the quotient. So the ln of x minus 1 squared over
X squared, right?
and how do you factor it? And can you make do this?
Times 7 X.
Yeah. So that'll be up on top. Is that cool? And then what happens there? What's the last thing? Yeah, one of the x minus 1s goes away. So you should get that. Hopefully you got that. You see past Jeff. Good job, past Jeff.
So log minus a log is basically the same thing as them being divided, and then a log plus a log is the same thing as being multiplied.
Yeah, and I think you guys could handle this real quick. If I had log, so what I'm saying is log base b of mn equals log base b of m plus log base b of n. Is that cool? That's what I'm saying. So log base b of m, let me switch here. I'm going to try to do this quickly, but hopefully this helps some of us. Do I know what that is? What's log base b of m? I don't know. Let me call that y. So what's b to the y? Is m. And the same thing with log base b of n. I'm going to call that, let's call that x. It's crazy. So then b to the x equals n. I like it. You guys with me so far? All right. So if I want to investigate this, I need to know what m times n is. What's m times n? What's m times n? B to the x times b to the y. Right? And that's b to the x plus 1. Take x. I like it, right? So I can piece this together. Let's see, so if I do, let's see, yeah, so watch this. So what's log base b of mn then? We just figured out mn is bx plus y, right? Y's got a big B on. Oh, it is a big B. And what is that? What is that? You can do it, yeah. Say it louder.
X plus y.
X plus y. Because these, what do these do?
They cancel out.
Cancel. So you get x plus y. But what was x? What was x? The thing you're pointing to, yeah. And y was the other thing. So it'd be log. Here's y was log base b of m, and x was log base b of n. So there you go. Log base b of mn is that. That's the proof. Remarkable. And real quick, if you'll realize that if I have log base b of m over n, isn't that log base b of m times n to the negative 1? As I say this in my head, why not? Is that not true? Of course, it's totally true, right? Of course, because what's n to the negative 1 want to do? Let's go back down. So there's the same, right? There's the same. If you force somebody out from its denominator to the other place, or its numerator to the other place, it's got to be to an opposite power, or a negative power. Right? Maybe. And so that explains why you can actually use this whole thing, and we have a minus sign there. All right, that's enough. Because I don't think I showed you that proof. I think I just talked about it more generally. That they are powers, so they have the same properties as powers, but that's the proof of it. So you don't just take my word for it. John's like, good. I'm tired of doing that. Never should do that. Alright? Anything else? Let's go in here. Oh. everybody. Which one that is? 4? Number 15? 15. Oh yeah, cool. Alright. I like 15. It's got multi-steps to it. Whenever you hear your instructor say, I like this kind of problem, you should probably make notes of that.
It sucks.
Huh?
Yeah, it sucks.
Yeah, and that'll probably be on the final. So this is 15 from the practice final. All right, dude. So 15. So we start with this here. Hopefully. So when you're trying to convert from polar equation to a rectangular equation, what are you looking for? Give me an idea. What's one thing you're kind of looking for?
R squared.
R squared. It would be awesome to see an R squared because you could replace that with
X squared plus
X squared plus Y squared. So if you don't see an R squared, if there's just an R there, one thing you might want to do is multiply by R, or you might need 2 squared to make it become R squared, right? What else am I looking for?
sine, cosine. R.
Not sine, cosine.
R cosine.
R cosine and R sine, right? Because then those would become X and Y, respectively. Is that cool? So you're always looking for that. If you see a portable sine dude just sitting there all by himself, what does he need? An R. So more than likely, you'll have to multiply both sides by R so that he'll get it, right? All right, so let's piece all that stuff together. So what do you think? If I see a cosine theta, I'm going to multiply by R to give him R cosine. What if I see cosine squared theta? How many R's does he need?
Minus an R.
What's X squared in polar? What would we replace X with? What's X in polar?
R sine theta.
R close.
Or cosine theta? So that would be what? R squared?
Cosine squared.
Cosine squared. Shit. So, alright. Everything we just said. What's he missing?
Square.
An R. What's he missing?
No.
R. What's he missing? Okay, cool. I can take care of that easy. What would suck is if one was missing an R and another one was missing 2 R's and this guy doesn't need any R. I mean, that would suck. That's where you start to try to do something else. Maybe you try to make tangent show up. If tangent theta showed up, what could you replace that with? What's tangent theta? Y over X. Yeah, that's what we've known ever since section 5.1. Alright, maybe. So we know what we got to do now. Thankfully, everybody agrees. Everybody needs an R. I'm like, oh, thank God. Let's give you an R. This is what I call the Jesus R in Math 280. I told him, because there's just one R. We only have one R. But, of course, all of a sudden, it's enough for everybody. Oh. Whatever you're with. Okay, good. I like somebody got embarrassed by how much they like that. I like that. Cool. And, of course, if you're not, I don't know if you're not religious like that, maybe the flying spaghetti monster gives you some of his noodles, right? Whatever way you want to go. So then, once I do that, multiply both sides by R. Here I get R squared plus 4R sine theta plus 3R squared cosine squared theta equals 0. 0 just eats that R up. So then I can replace this with
X squared plus Y squared.
X squared plus Y squared. This
4Y.
4Y. This
3X squared.
3X squared. Kick ass. So you should right now know, if you're careful, well, let's see, what shape is this going to be?
Ellipse.
Yeah, why ellipse? Why not circle?
Different color.
Yeah, somebody might focus on that, but you got like terms, so that would be 4x squared. Now, what do I have to do with this
Complete this one.
Beautiful. Okay, good. I like it. I like it. So then, of course, what goes here?
A 4.
4. So over here,
Nine.
4. So
Wait, wouldn't it be?
half of 4 is 2 squared. Is
Why is it 4x? We only have an x.
Because of the previous.
Okay.
yeah. So then I get 4x squared plus y plus 2 squared equals 4. Is that in standard form yet?
No.
Nope.
Divide by 4.
Divide by 4. You want a 1 over here, right? So I end up with x squared plus y plus 2 squared over 4 equals 1. Where's the center? Alright, stop there for a second. So now you can get the center, you can get the semi-major, semi-minor axes, lengths, right? What would the center be? 0, negative 2. This would move back, down 2 in this case, right? If it's in with the letter, it's the opposite. And I don't know. Let's start something new. Let's call it AX and AY, not A and B bullshit. I like that. Of course, if I start doing that, students will be like, "Well, you're doing it different than bullshit." A and B are kind of dumb because they don't get connected. They have to change sometimes. Screw it. Let me just call the thing with X AX and the thing with Y AY. Whatever you want to do. What's AX? 1. And what's AY? 2. You guess. How do I get C? Square root of 4 minus 1. C squared is A squared minus B, or whatever your A's and whatever. Whichever one's bigger goes first. But it's the squares. I get too many people doing 2 minus 1 and getting the wrong thing there, right? So rad 3. Whatever that is about. 1.7 something. Are y'all with me here in this? Okay. So even if it's off-center, ellipses normally are ones you go, yes, ellipse, give me that. Alright, so this is off-center, so I just get the center going. So the center would be 0, negative 2. And then I'm not going to count very far away, so I can make my scale. I don't have to make a crazy scale. So there's my center, so let me put a little circle there. Open circle, so I'm saying that's not farther, right? X's I normally reserve for foci, right? Foci. So what do I do now?
Up and over 2.
Yeah, good. Go 2 up. And that's why I kind of like this. It's really easy to tell. In the X direction, go 1. If it's A and B, you're like, shit. What's B? Anyway, sorry. So you would go up 2, down 2, right 1. And all of these are actual points, right? Because this is a nice ellipse. If it's hyperbola, you only fill 2 of those in. Whatever the actual, if it's going to be like that or like, I can't do that. Like that or like that. Screw it. Right? You gotta be careful. Only 2 of those would work. This is all 4 of this. And then you're basically done. The foci, so that would be, where am I going to put it? Which direction am I going to go? Major axis, good. So it would be up 1.7, down 1.7. You don't have to be perfect. It just makes sense that it's inside. And then you draw in your little, all right, not too bad for me.
Yeah, perfect.
Huh?
Almost perfect.
It's crazy. Don't raise the bar that much for me. Remember that one time you drew a perfect, Jeff? Never again. Damn. All right.
I was wondering, do you have another sheet with all the trig identities? Because I can't remember what identity you used on the last step of question 13.
Not with me. but it's, I don't think I did put it up on the website, did I? Anybody know if it's up on the website? Oh, there we go. Yeah. Even looked, but I'm pretty sure it's not. No, that's good. I know what I'm talking about. So somebody said something about trig identities, and we didn't do any of that yet. So remember, yeah, you want to go back and look at the above the black bars, what I'm going to expect you to know. And you know I'm going to give you problems using those so I can actually see if you know it. So you have to know like the half angle formula, the double angle formulas, the basic stuff, right? The basic three, the big three, trig identities, right? What else is up there? I can't remember.
Log cosines, log sines.
Yeah, log cosines, log sines.
Cofunction identities.
Oh, what to do.
Even and odd identities.
What to do.
Reciprocal identities.
What to do. Alright, nothing major.
No,
Easy for you, so Jack. But remember, so real quick, without looking at the trig identity sheet, can you write down one way to rewrite this? Alright, I like it. So I always start here. Cosine squared minus sine squared. Because from there, I can, and of course from any of them, you can get the other two. But if I replace this with 1 minus sine squared, that's 1 minus 2 sine squared. If I replace this with 1 minus cosine squared, that becomes 2 cosine squared minus 1. So put my like terms together. Alright, so I only have to remember one, but there are two more. 1 minus 2 sine squared, 2 cosine squared, minus 1. Those are all equivalent. They're all the same. It shouldn't be like a magical, it should be amazing. Cosine squared and sine squared are directly related. They should be the same. And then this guy is nice because he only has
Two sines.
Yeah. How did we prove this? We proved this a while back. We proved it. How did we do that?
Very confusing.
No, you're not thinking about the right one. How we proved this when we proved that thing. That was the monster triangle that had several versions. That yummy, that awesome day. We're so happy you came. Yeah, you got the sum and difference formulas, right?
Yeah.
So if I had sine A plus B, what was the thing I said? I don't know if that helps anybody out. It helps me out. That's all I care about.
Sine A, cosine B plus sine A.
Cosine's an asshole,
Yeah,
right?
he takes the...
So sine is nice. Sine says, let's just take a turn, cosine. There's a plus there, cosine. Let's leave it the plus. And then cosine says, fuck yeah. And there's a plus, screw that plus. Right? I don't know. That's the way I remember. That's the way I think about it. Now, obviously, there are ways to remember something which are very often very different from why things are the way they are. Right? So this is what we use that giant triangle for. The book gave you an entirely different proof of these. Right? So if you want to look at the book's proof and see if that makes more sense, I just always hate the book's kind of approach. On that problem, I hate the book's approach. It's just not satisfying to me. Now, if this was a minus, there would be a minus. Because again, the sign's nice. Whatever's there, let's leave it alone. If this is a minus, this is a plus. Good. So now that shows you why plus minus is not the same as minus plus. They actually indicate different order. Right? What about how can I rewrite cosine squared? Not 1 minus sine squared. It's a little more interesting than that. Who remembers that? And actually it comes off of this. If I solve this for cosine squared, I would add 1. Divide by 2. Yeah, so what's funny to me is the half angle formula for cosine and the half angle formula for sine really just comes from solving these. So cosine squared theta equals cosine, let's just do it in the right order. 1 plus cosine 2 theta over 2. You guys with me? Now remember, we had a whole discussion about the form of an identity and how that relates. So if I said cosine squared 2 theta, yeah. So 1 plus cosine 4 theta over 2. Sweet. That's still a 2, right? That would still be a 2 there. So this form says whatever is here, I put twice that there. That's what that form says. And remember, we talked about if I said sine 4 theta, and then a lot of people's first reaction was to say that's 4. That 2 is there because there are 2 terms here, right? That's why. So that's 2. You ain't screwing with that. But it says sine of twice an angle is 2 sine that angle. Oh shit. So what's the angle going to be? What's this twice? Yeah, it's going to be 2 theta. 4 theta is twice 2 theta. Does that make sense? I mean, there's that whole idea about how to appropriately use an identity or an equation. Put the right thing in the right place. So normally you see this one here. If you look at the half angle identity, if I put cosine of theta over 2, I'm doing 2 things at once here. So I took a square root. Is that cool? Because that's the way it's going to show up on your thingamajig. Whatever's here, what goes there? Twice it. So there's theta over 2. So what's going to go here? Theta. All right, sweet. So that's why if I ask you for cosine of 22.5 degrees, well, that's going to be square root of 1 plus cosine of 45 degrees over 2. That's the half angle formula. That's what it's useful for that evaluating half angles. It's crazy why they call it that. So here's a problem that I've given you before, and I'm going to give you again. Let's see. I like that problem a lot. Okay, sure. If I set up a triangle, what am I setting up a triangle for? What part of this? The inverse tangent. The inverse trig functions can be represented. They are angles that live in a triangle you could draw, even if it doesn't exist. You can still draw the triangle to represent it. I don't know if anybody really understands what I mean when I say that, but I'm going to keep doing it anyway. Because then, whatever this is, this piece, that's the only piece we're talking about right now, right? So people always see that 2, and somehow they just double what they get. They're like, oh, the 2 just doubles things. That's what 2 does. But no, this is sine of a completely different angle. Shit. So when I set up this, so if I call this theta, this is sine of 2 theta, right? And this triangle has a theta in it. So the question is asking me about a completely different triangle. So I can't just double the answer I get. No, that's not how it works. But let's see, what do I know for sure then about this triangle? Yeah, where's y go?
Y.
Oh, the y, good. That might be why I called it. And 3 goes there, so what's the hypotenuse? Okay, square. So you can't just plug shit in here. I don't know what theta is, but I know that the triangle that has theta in it has those sides. Or could be represented with those sides. So how the hell do I answer this question then? It's probably got something to do with something on the board. Yeah, huh? Yes, this guy. So sine of twice theta is 2 sine theta cosine theta. Get out of here. Your parenthesis. So sine theta, I can see what it is. Cosine theta. And why is that better? This is asking me about an angle I know nothing about. If I rewrite it, now I know everything about theta. I know everything about theta. So I have to rewrite that when there's something in the way. A 2, for example. And you've seen that kind of problem where they put like inverse cosine of something here and inverse tangent something there. So you have to rewrite it with this identity, right? You've seen that in the homework, believe it or not. So that would be something like sine of inverse tangent of y over 3 plus inverse cosine of x over 2. So each one of these sets up a triangle, but what's the angle that this wants? The whole freaking thing. I don't know shit about that one, so I better rewrite it so I can attack each one of them directly. Then I can use the triangle directly. Hopefully. There was a decent number of those kind of problems in the homework and on the test. If you look back at the test, I actually gave you one that was a lot like that. Gauging your reaction, I'll definitely put that one on. If you guys look worried, you're like, let's look super happy about everything. Oh, cool, you'll be happy when I put it in the test.
Alright, just do that exact thing. You would just do
some. It would just be twice. You'd set up a triangle, so if you call this angle A and you call this angle B, you set up a triangle here. And so for this one, it's asking for sine of A, right? So then that's going to be y over that. You with me? Yeah, you set up this triangle, so anything that's talking about B, you can look at it. Anything that's talking about A, you can look at that one.
So you just pull values from the triangle.
Yes, cool. Because I can set up two triangles separately that deal with A and B. I can't answer this question. I don't know shit about about angle A plus B. I don't know a damn thing about it. But if I can rewrite it so it's all about A separately from B, then I can answer that all day long. I got triangles set up. I can answer you anything you ask about this. This semester I've had a lot of people look at me like they want to kill me. I'm kind of used to it, but it seems to be more this semester for some reason. And sometimes, I actually had somebody, the whole semester I thought she hated me. I thought she would come to class and she would just, at the end of the class she said, I really enjoyed you. I'm like, what the hell? So I don't even think about it.
RBF.
Yeah.
RBF.
What?
17.
17. Oh, all right, partial fractions. I'll tell you this. You see how number 7 is sitting there? So one thing I could use number 7 for is to make you do a problem like number 8. Right? Where once you factor using synthetic division, then you do it. But it can also give you a problem like number 17, the bottom of which you would have just done using synthetic division. You guys kind of with me here? You could totally do that all day long, right? So be careful. Always look, whatever you just do, see if it shows up in the next thing. When you have a problem, when you have a test for me. On this one, I don't have to do all that, do I? The bottom is easy to factor. Maybe. And of course, how to factor the bottom is just grouping, right? So if I take an x squared out of the first, so you guys can handle this.
X minus 1.
Yeah, if I take an x squared out, it will be x minus 1, so it'll be x minus 1, x squared minus 1. So it'll be x plus 1, x minus 1, x minus 1. If you're not with me, just do it. And now, why did I know I could start doing that? I didn't have to worry. What was the first thing you really should check in a partial fraction problem? Powers. If they're the same or the top is bigger, you have to first do long division. Now here, it was second degree on top, third degree on the bottom. We're good. Right? So you just start going for it. How do I set up the form of the answer?
A over x plus 1
Good.
plus b over x plus 1 squared plus c over x plus 1. Or x minus 1 squared.
Alright, so you need an x minus 1 by itself for the c, and then you need an x minus 1 the second time around with the b. Because they are both officially first degree. It's just that it's been repeated a couple times. Right? Maybe. You have to have that. So what's the steps here? What do we do next? Yeah, multiply by the LCD, and hopefully you guys are to the point where you just know what he's going to get. If I multiply by the LCD, he's going to pick up the other stuff, because that would cancel, right? This guy's going to pick up x plus 1. This guy's going to pick up
X plus 1, X minus 1.
Good. And now it's totally up to you which way you do it. I would like to do letting x equal certain things. Whenever I can, normally that's the way I do it, unless it's a really tiny problem, quick problem. This has got 3 letters, so I might start there and see how far I can go with it. Yeah. So if I let x equal 1, I get 1 plus 8 minus 1 is 8. And over there, the only thing left alive is the b in the middle, so yeah, 2b. So b is 4, kick ass. Somebody with me on that? I mean, if you don't like this method, you could just FOIL, distribute, get your like terms together, and then make a matrix in this case, a matrix of equations. If you really, really want to, that'll work. A system of equations, blah, blah, blah. This is just so much more cut through everything and just get to it. What else would I let x equal? That's crazy. So I get 1 minus 8 minus 1. Negative 8. And then what's left alive over there? That dies. Yeah, a is left. So negative 1 minus 1 is negative 2 squared is 4. You get 4a. So a is negative 2. Cool. So what's the only thing I have left to figure out? C. So let me see if you guys remember this. The whole reason I did this was to try to escape foiling and shit, right? So I really don't want to have to foil right now to do anything. I did this at least once. I can just focus on what I need to relate to C. So C would have, this would be x squared minus 1, right? So I can look at either the x squares or I can look at the constant terms. Those would connect C with the other two. Do you guys understand what I'm saying? C has nothing to do with the x by itself, because C is not attached to an x by itself. Right? C is attached to an x. So if I look at the x squared stuff, this would be a times x squared plus other shit. So all I care about right now is ax squared plus, do I get any x squares from him? No. Screw him. And over here I get cx squared. Has to be 1x squared. So a plus c must be 1. A is negative 2. C is 3. Yes. So then finally I can say this equals, just put everything back in the right place, right? Negative 2 over x plus 1. So forth. Right, and if you would have called this C and this B and this A, then they would have gotten the appropriate values at the end. The process doesn't care which is which. It just needs a place to put a number.
How do you get ax squared plus 2x squared equals 1x squared?
So if I FOIL this out, won't I get a times x squared plus other crap that I don't care about? Why am I saying that? Because the only thing I don't know is C. And what's C going to be attached to? An x squared and a constant, right? So I can either relate all the constants to each other, or I can relate the x squares. Now, who knows why I chose the x squared? Because
This lesson?
This guy doesn't have an X squared. There's less stuff to worry about. So I'm equating coefficients, but I'm not fully foiling this shit out. I'm just taking what I need. Now again, every time I show you a shortcut, if you're not comfortable with what I'm doing, you just do it. Just do it all the way out. Foil that bad boy, bring the A through. Foil that bad boy, distribute, foil that out. Blah, blah, blah. You'll still get there fine. Yeah.
So for the problems like number 16, when we use a matrix, do you want us to use the full row echelon form, or do you mind if we use substitution instead?
Oh, what do you think?
The full.
Yeah. Because that's what's new. That's what's new. Awesome. That's why I'm going to put down at the end and say, those of you who can't pass a problem and go forward, there are people that just can't pass a problem. So if I put that one at the end, then you won't waste a lot of time trying to figure out something. And again, it's almost impossible. There will be at least one person, probably 20, that will make a mistake because we're all human. So you'll have a negative that you should have put there that you forgot, right? So what I'm most interested in that problem is show me that you understand the approach. Show me that you understand the process. If you start getting fractions, you can just come up and say, "Can you see what I did?" And I'll say, "Oh, you forgot the negative." I mean, if it's just that, I'm going to help you. Why not? I just forgot the negative. I'm not giving you information about the process. I'm just telling you, "Oh yeah, you need a negative there." Now keep going. You guys with me on that? So the intent on that is not to be a busy work problem that just sucks your time away. The intent on that is just show me you understand the process of what to do.
How many questions are going to be on the final?
It's going to be a little shorter than this. We have a little bit more time than normal, and my normal tests have like 20. Well, if you add up all the ABC, somewhere around 20. So this test should have around 24. If you add up all the ABC. You can make it 12 just. It's less for you to grade, man. Oh, you guys are so selfish. Don't worry about your Jeff so much grading. Make it test shorter, man. Yeah.
So is pretty much every idea that we've done in the practice final, is it for sure going to be on the final, or is it just like, preparation?
That's every teacher's favorite question. There are things that are not on the final that a student would claim is not on here. That will be on the final. And the reason they would claim it's not on here is maybe it's an absolute value problem that doesn't look like the one that's on here, right? So there's a certain level of, I'm not going to just change the numbers and then give that to you as the final, right? You have to understand the ideas. If you understand all the ideas that are on this practice final, you should be able to attack the final itself. Bam.
We don't need to review like every single section.
No. You look at this and you try something, you're like, I know how to do that. No, that's the one I'm not sure about. Let me go back to that section and do some out of the book. Some odd ones so you can see the answers, right? That's the real way to use this to study. This is supposed to guide you towards what you need to focus on.
You are gonna put like the graph or like graphing sign for it, or because it's not on here. That's what it's on.
Probably not. Do you notice how I said probably not? But I'm almost right. Yeah. Anything else you guys are worried about that isn't on here? I mean, for example, number 6 is raising a complex number to a third power. I could have on the final, take the fourth root of this complex number. That's what I mean. So that problem represents that type of idea, right? So you have to make sure, do I totally understand everything involved with that kind of thing? Yeah, I don't see anything I left off. There's nothing specific on here about geometric and arithmetic, but I can totally have something on there about that, right?
Inverse matrices, like on the 3x3.
So I don't want to say no, but you have to think that kind of problem takes a while. Yeah. So when I'm making the test and I have time constraints, you can kind of figure out maybe what I have to cut out if you feel like gambling. But that's not that bad, right? And the reason, to find an inverse matrix, what skill do you actually have to have? The same skill you have to do number 16. So if you can do number 16's problem, you can totally find the inverse of the matrix. The one thing you have to remember is you put next to it the identity matrix. That's the one thing, and then it's just like number 16, right? So it's more of a, what skill do you have to be able to do this thing, right? Instead of, you don't have this on there, but I've got the skill on there that you need to do it. You're never going to get a teacher, well, if you do, they should really get out of the profession, but there should never be a teacher that says, there will be this and exactly this, and this won't be on that, this won't be on that. Why is that? Why do we do that? Why are we so evil like that? Why do we have stuff that we've learned and stuff that I focus on and then it doesn't show up on the final? Because the point of this class is not to pass the damn final. The point of this class is to understand the ideas that we talked about. Period. Right? The final is an imperfect way for me to judge how well you know all the stuff we talked about. Imperfect because we don't have all day to do it. Right? I don't think that would work. There's somewhere between a perfectly length test and how much you guys can handle before your brains short circuit. Right? Hour 7. I don't know. I just drew a picture of a pineapple. I want to grade that test. On one page is all math and no play. It makes me a dumb boy. Oh shit. Just all over the place. I'm like, oh crap. They're walking out there somewhere.
The last one is just tears.
You circle like, these were teardrops. Oh, good, alright. Blood, sweat, and tears. You guys are lucky, you get the first day.
Yeah.
Get it out of
So
the way.
lucky.
I'm giving a stats final on Monday, June 1st.
Ooh.
Yeah, they go that far. Yeah.
That's not my time.
Is it the same time?
School week. I can go back from my last weekend.
So it's on the sheet, what is it? 9:25.
And then I had that one.
9:25.
I would take that easily because I was like, last weekend I'm directly studying, and then Monday comes, you still studying, and Tuesday comes, fuck, I'm great.
I was sleeping free time again.
Yeah. I was doing this class with general and 2 other classes.
Ooh, Canada.
This class and my general class is 11 minutes. So.
Yeah, that's pretty much the same boat I'm in. It's this class in Spanish, which is 11 minutes. Spanish is, at first it was difficult because I've never taken a Spanish class in my life. But after you get in the hang of things, it starts to click.
You know how in chemistry 120 you only have one lab.
It's all about what you guys need to talk about. If you don't need to talk about anything else today, then we're done.
That's 2 labs a day. 2 lectures a day.
Corrections.
It's just like I found this good every time of day.
Yes.
Like 12 minutes like, want to commit to work. Not really.
You're on campus tomorrow, correct, sir?
No.
No?
Nope.
Are you playing with me?
Huh?
Are you joking or no?
No. No, I'm not. Tomorrow's Friday. I don't have a meeting here. I didn't really plan on coming. Why?
Just asking.
Oh, sorry.
Look, I saw you last Friday.
What's up?
I thought you normally come on Friday.
Tomorrow's Friday. Don't mess with me.
Well, I saw you Friday last time leaving from the Dean's place. That's why I thought you.
Oh, I had a meeting. Oh, yeah. Fridays are meeting days.
So I gotta go clean my tongue up.
Yeah. Yep.
And then for the grading, when like, you're grading it, like you're not gonna worry